Hello friends, welcome back to the Dr. Tristos channel. I'm Dr. Tristos. We're happy to have you here today. Today we want to spend a little bit of time talking about the eZ80 CPU. I touched on this in the overview video, which is the first video we done. The eZ80 was the answer, Zilog's answer to replacement of the Z80. As people have seen now in the news, the Z80 chip has been officially discontinued by Zilog. Of course, it's going to be around for a long time yet. However, they've ceased production of new chips and research into that particular platform, and they've committed to their eZ80 series. I want to point out that also that this is eZ80 Acclaim series. So let's jump into this. If you wanted an eZ80, there's a lot of places you can buy them online. You simply Google however, products that already have it included, ready to go to run software, is the Agon computer or Circle M hardware out of Canada. Build some really nice CPM based computers that can also run TrisOS and ultimately Tristos. So the Zilog website, it's at zilog.com. We can find information about their latest products. And the eZ80 is listed here under the eZ80 Acclaim. Well, we have a development system for that, and then we have a smart cable. And what the smart cable does, you'll hear us talking about that we need to download or program the eZ80 system, and we use the smart cable to do that. Many products already include the programmer's port on the board. I know Circle M includes this. You can solder it on yourself. I believe the Agon has the programmer's port internally. So let's see what we need for that programmer's port, which is the smart cable. These can be ordered online. I see them on eBay. You can also order them at various hardware vendors. We have this programming box that's part of the smart cable. Then there is a 6-conductor flat cable. It's just a flat ribbon cable, 6-conductor, and a USB cable. As you can see from the diagram here, your PC-based system, you plug in the USB with this small programmer module, and then the 6-pin cable plugs into the port on your project. Now, you would typically use this to be able to run the Zilog Development System, the ZDS, which we'll talk about here in a few minutes. But the ZDS can download directly into RAM, the flash memory that's on the eZ80. It can also start and stop execution, examine registers, examine memory. You can do that all through this programmer's port. It's really for an assembly language programmer who's trying to debug system level code, BIOS code. It's really a godsend. This can be a little pricey for this one device. I have seen, I believe it was on Hackday.io. In a few places, people are trying to make a compatible programmer. But this is what you need. You will also you find sometimes used ones for sale that are serial based and Ethernet based instead of USB. I have not used those. I don't know why they wouldn't work. If you had a a PC with a serial port or a Ethernet port to spare that you could, there would be no reason that they wouldn't work. I just have never used them. I've only used the USB model. So these make a great a great way to program. And also, I want to let you know that the Z8, which is another popular microcontroller from Zilog, it uses the same programming cable. So if you have the programming cable from one, you have it for both. Back at the home page here again, we can see at the bottom the ZDS2 eZ80 Acclaim 5.35. ZDS is Zilog Development System. The ZDS2, if we click on this, it will take us directly to their licensing page to accept the license, and we could accept and then start a download. Now, this software is completely free, and one of the great advantages of the ZDS software is that it has a simulator built in for the eZ80 and a simulator for the UARTs. And so we can write simple programs, have them write to the UART, which will display in a small window. We'll show you this later and in later videos. But this allows us to develop code, run it, and see the results right inside the development system. For this, you would need no hardware. You would not need a programming cable. You would not need a development board. You would only need this one free piece of software, and you could write simple programs, have it print hello world to the UART, and be able to see that on the screen of your PC that you're running the development system on. That's a great advantage for debugging and developing. So again, you can come here and download this software, and you'll have a complete development system with a linker, loader, assembler, and also a C compiler. These are all integrated to work together in this one development package. So our hats off to Zilog on that. It's been a great help. Also, if you look on Zilog's website, you'll see that they have a Captain Zilog. There's a comic book for Captain Zilog. I think his days have maybe passed since he was promoted by Zilog. However, they had their own comic book, and Captain Zilog always came to the rescue. And I was reading, seems like it's a lot of a combination of Superman and maybe Batman rolled into one, becomes Captain Zilog here. So we want to give a special shout out to Captain Zilog, and maybe sometime he'll join us here on our channel. We have a wonderful canine. Since we're talking about comics, we also have a wonderful canine outside. Her name is Cece, and she always gets excited when Captain Zilog comes on the screen, or we just start talking about the eZ80 and Zilog in general. It's an exciting topic that even excites the canines in the community. However, we'll move on now, and let's look at my website here, danielpaulmartin.com. That's www.danielpaulmartin.com. And if we go under my research, which I've said in previous videos, the only thing I research today is my own personal hobbies, we will see a block diagram down at the bottom of both the F91 and the F92, the two Acclaim chips that we currently support with TrisOS and TrisOS. There is an F93, but I have not done a port to that yet. However, the F91 and F92 both are supported. I want to point out here the F91. We have a eMac or a Mac, Ethernet Mac, a NIC interface, and there's 8 kilobytes of static RAM internal in the CPU dedicated to support that Mac. However, if you're not using the Mac, you can use the RAM for general purposes. It also has 256 kilobytes of flash memory built in, and we have a real-time clock. Keeps time of the keeps track of our time for us, and a SPI. I'm sorry, an ICE interface, I2C, and the hardware for that is built in, along with a SPI interface, which we'll be using for SD cards and other type hardware. So this serial peripheral interface, the hardware is built in the chip, along with the other things, the memory here, the RAM, the Mac. We have a UART. We have 2 UARTs, 0 and 1. These are great UARTs. I have programmed them extensively in assembly language, interfacing to legacy devices, new devices, PCs, TRS-80s. They really work wonderfully, and I believe we're going up to 1 megabit per second, the baud rate, or slightly less. That we have tested that with on the Agon for video. As long as I provide handshaking, I'm not using them interrupt driven, simply because of the complexity of the driver pushes it past the memory footprint that I have in Tristos to use. However, I've used these up to the on the Agon up to the 1 megabit per second range, and with handshaking we don't drop 1 bit. It works perfectly. We don't have an overrun. We seem to be able to keep up just fine. We have an interrupt controller, and this is really very valuable. With all these new, we have, for example, let's look down here. We have IRDA, encoder decoder, general purpose I/O bits. I believe there's 32 on the F91 here has 32 spare digital I/O, and you could program these for anything. You could program them to create your own TRS-80 bus to access old peripherals for a TRS-80, or you could use them to create your own parallel I/O for interfacing around your home or your business, or for control applications, alarm systems in a car, a vehicle, controlling motors. It's really great that they give you these 32 general purpose bits to be used however you want. And there again, if you're building a hobby project and this saves you a lot of time. You already have your digital I/O bits right here. You can move on to the next phase of your project. What is it you were wanting to interface to, and you can get right with interfacing that system, and not have to fool with, well, first I have to build a DIO for the Z80 board. Well, here we've just done a lot of that work for you. Along with the clock circuitry is built on. We have programmable reload timers. We have 4 of those. We only use 1 in Tristos. This generates 60 hertz interrupts for us. And the other programmable reloadable timers, there's whatever your imagination or your project could lead you to use these for. We have a watchdog timer. If you don't know what a watchdog is, we can set a watchdog up that if you don't clear the bit every so many milliseconds, up to seconds, I believe. I'm not sure the limit of how long we can set it, but if the bit is not cleared regularly, then the watchdog is going to assume the software is not running right and give you an interrupt. And you can have a routine then that examines your CPU and determines, is it the program running correctly, or do I need to try to do some type of restart? And so then that brings us back to this interrupt controller. This helps bring all of these peripherals that use interrupts. Having an interrupt controller built in, that saves you a whole lot of design and building time for building a project, that you now have that in here. Moving on up, we have our chip select and wait state generator. Again, this is hardware built onto the CPU chip that you can use. It'll save you a lot of time in building your projects. We already decode 4 chip select signals that can be used to interface with memory, and a wait state generator coming back. So if you need to program wait states, or you need to generate a hardware wait state, you're all set up. The hardware is already built in the CPU. Now we have this JTAG/ZDI, 5 signals on here and a ground. That makes up our 6-pin cable for the programmer's cable. The ZDI, Zilog Development Interface. So this is where our programming cable plugs in. It's, as you can see, tightly coupled with the CPU itself. The debug development, Zilog debug or Zilog development interface is closely coupled with the CPU. This allows us to be able to view the CPU registers on our PC, the memory that the CPU is using. The development interface can get at all of that data. And again, we have a bus controller here. That if you're a Z80 builder, you'll notice most of these signals look very familiar. Read, write, bus acknowledge, bus request for DMAs. And I said down here was the 8K for the 8K of RAM for the Mac. I'm sorry, the 8K for the Mac is up here in the block diagram. This down here is a general purpose RAM at the bottom. So it has 8K of general purpose RAM built in, and then we have 8K for the eMac also. If you're not using the eMac, these can be used. The one at the top here is general purpose memory. If we want to look down, the F92, I call it the little brother. Its main its main advantage is a lower price target. Things have been stripped out of the design, such as the NIC card, the NIC interface. We no longer have that here. We put in less RAM and less flash. Here we have just 8 kilobytes of general purpose RAM and 128 kilobytes of flash. However, we do have an option here of 256 bytes of general purpose flash. That gives us 256 bytes, not K, 256 bytes that we can use to hold configurations, hold data from one bootstrap to the next. But then our main 128 kilobytes of flash can be used to hold boot code. I need 16K of RAM to run a version of Tris-DOS that would be pretty stupid. I mean, it would only have 16K of RAM. Tristos will not run out of ROM or flash memory. It needs to run out of RAM. I would need a 16K window to do that. None of these chips have a continuous block of 16K RAM to where perhaps I could try to make it all self-contained and run inside one CPU. So run just inside the CPU. So to run Tristos, we need external memory, and normally we use the flash here to hold a bootstrap program to bring TrisOS up. So those are the two CPU chips that we're dealing with. The F93 here at the bottom, I have a note. It has 64 kilobytes of flash and 4 kilobytes of static RAM. So there again, they're stepping its features down another step. It's going to come in at a lower price point. It has less flash, less static RAM, and I believe they perhaps also changed some of the peripherals. Again, this is the big advantage to using the eZ80 is, well, we have standardization of the serial ports, the clocks, the timers. Currently, if we build a Z80 project, your project, more than likely the addresses for the serial port and the timers, etc., their bit patterns for their registers and the addresses of their registers would be different. So I would need a version of software for each individual project. One big advantage with the eZ80 chip is that's all standardized now. If you write software that's running on one person's project, it should work on another project that uses the eZ80 also, in general terms, simply because of the being able to use the same serial ports and your timers and clocks, etc. They're going to be laid out the same on both. Now there is some differences between the F91 and the F92, such as the interrupt structure. They use a completely different vectoring tables, etc. TrisOS, when it boots, it detects which CPU it's running on. Then it adjusts itself internally to whichever CPU it is. So it will use that CPU correctly. This way, I have one load module. It will self-configure to either CPU. If you boot it on a 91 or you boot it on a 92, it will detect that and it will adjust its internal tables and support for peripherals. It will adjust that, and you, as the user, it's transparent to you. The Wikipedia page here has a picture of one of the, this is as I understand from reading this is a used in the TI-84 calculator. We see that a lot of popular support groups and people program this calculator. They program this eZ80 inside, but Wikipedia here has a short description and the register layouts. Now, registers have been extended to 24 bits, but you don't have to use the 24 bits. And also, we know that it can seem a little overwhelming to be running a Z80 project, and you're very familiar with that. You have a good knowledge of what's going on with it, and folks come along and say, let's convert to the eZ80, and one evening you sit down to do that, and if you add it all up, there's several thousand pages of manuals to go with the eZ80. You have the smart programming cable, you have a development system, you have a new CPU with all these peripherals and so many things to learn, and I understand. It can really seem a little overwhelming. but I want to assure you that you can program this eZ80 almost exactly the same, almost binarily compatible with the Z80. Very few little differences. And you will find that once you start using the development system, that it is easier than the Z80 was. Everything is all built into one suite. It's right there. Once you learn what tools there are and when you need to use them, it becomes much easier to develop code. You do all the development work on a PC, and you have all the modern PC features and advantages. I know that it seems a little overwhelming in the beginning, but you just have to trust Dr. Tristos that everything will be okay, and very quickly you will be up and writing code on the eZ80 better than what you did on the Z80. The folks at Zilog, and let's remember Captain Zilog, they know what they're doing. So when they set out to make the eZ80, they stayed compatible with the Z80 and all the programming that you'd learned how to do on the Z80. They just added more to that. They just gave you more tools, more advantages, more powerful tools, standardization. Everything works the same for everybody now. So if you develop a project and I develop a project, our basic core of that project, our peripherals will all work the same way, the same addresses. We should be able to trade software around. That all begins with downloading the Zilog Development System here on the Zilog webpage for free and installing that on your PC. We'll have a video next that will show you how to configure. I understand that when you download this and bring it up, it may look completely Greek to you because it's a whole new world. We are going to make a video on showing you how to install and then set up your ZDS system, and then we'll walk you right through programming your first project. I want to thank you for listening today, and we hope that you will download the ZDS and get set up. Create your little workspace on your PC, and clear off a little place on your desktop, and allow us to have some space there, and we'll create some projects, help you learn how to program the eZ80 just like you were the Z80. If you have questions or comments, there is a contact form on my website. Again, that's www.danielpaulmartin.com. And until then, I hope to see you in the next video.